Twitter recently open-sourced their timeline building algorithm. This is a big deal because this is the first time a big social media company has done this. In this video, we're going to take a look at the code in excruciating detail. And what's this? Code that references Elon Musk by name? Was he using the algorithm to boost his tweets? Let's find out. But first, a word from today's sponsor, My Ass. Use code ASS for $5 off. Firstly, when we're talking about the algorithm, what exactly are we talking about? The algorithm refers to the code that determines what tweets you see in your timeline. It's a complex system that is made up of many different components. They're described at a very high level in various readmes in the repo and some Twitter engineering blogs. The general flow to generate a timeline is to first fetch a set of candidates, which are tweets that are candidates to be shown in your timeline. Then, these candidates are ranked based on some machine learning statistical model. Finally, these tweets are filtered based on user preferences, such as muting, blocking, not safe for work content, etc. This diagram shows all the major components of this pipeline. Let's dive into the first part of this process, candidate sourcing. There's two main sources of candidates, in-network and out-of-network. In-network candidates are tweets from people you follow. These tweets are ranked by a logistic regression model. This particular component is called RealGraph, and the paper for it was published in 2014. It predicts the likelihood of interaction between two users. Out-of-network candidates are tweets from people you don't follow. These tweets are mostly based on engagement of people you follow or those with similar interests. There's two parts to this, the social graph and embedding spaces. The social graph represents connections between users, and the embedding spaces determine similarity of tweets to create topic groups, aka communities. The next part of the pipeline is ranking. The goal of this component is to serve relevant tweets to users. It's basically a 48 million parameter black box that ranks tweets from candidate sources. It optimizes for engagement. That's about it. It's really not that interesting. After that, tweets are filtered based on user preferences and some heuristics. Think stuff like removing tweets from users you've blocked, or providing the context tweet for a reply. These tweets are now ready to be served. They are mixed with ads and other stuff, and then served to the user. When the code was first published, people were very quick to point out that there is a variable called author is Elon. This variable is used to determine if a tweet is from Elon Musk. Given his recent acquisition of Twitter, people were quick to jump to conclusions that this was a way to boost his tweets in everyone's timeline. In addition, there were other variables like author is Democrat and author is Republican, which raised similar concerns. This code referencing Elon was subsequently removed from the repo in a commit, but the question remains, what was it really used for? Let's dive into the code and find out. Code in question was in the home mixer component, which is written in Scala. It's basically a really big config for product mixer, which is what actually does the mixing. This component is responsible for mixing tweets with ads and other stuff, and then serving them to the user. So this occurs in the mixing step of the pipeline, which I would like to note is significantly after the candidate sourcing step, where all the tweets are actually collected. So I feel pretty confident that the mixer is not actually adding tweets. But suppose that an Elon tweet was collected by the candidate sourcing step. What would happen to it in the mixer? The string author is Elon appears in this file. It lists a bunch of signals that can be applied to a tweet. The author is Elon signal references a class called DDG stats Elon feature. DG stands for DuckDuckGoose, which is a Twitter internal tool used for A/B testing. as explained in this Twitter engineering blog post. A/B testing is a way to test out new features on a subset of users and then measure the impact of the feature. This is a very common practice in software development, especially at the scale of companies like Twitter. I have metrics for my own projects like OpenTogetherTube, and they can be very useful for determining what's wrong when something breaks. In this file, we can see a comment that says, "These author ID lists are used purely for metrics collection. We track how often we are serving tweets from these authors and how often their tweets are being impressed by users. This helps us validate in our A/B experimentation platform that we do not ship changes that negatively impacts one group over others." It seems pretty clear that this is a non-issue, right? The code is used for metrics collection and not for actually boosting tweets. But we keep seeing these things called features being referenced. What are they? Typically, in this context, a feature is a piece of data that is used to train a machine learning model. Think of it like a column in a spreadsheet. The home mixer's main purpose isn't inference, which is using a model to make predictions. So where are these features being applied, and which parts of the pipeline are using them? DDG stats Elon feature is a feature defined like so, alongside a bunch of other features. A feature in home mixer references the entity that can have the feature and the type of value of the feature. So DDG stats Elon feature is a feature that can be applied to pipeline query, and the value is type long. This is different from some of the other features, like screen names feature, which can be applied to tweet candidate. This and other context in this file indicates to me that the home mixer actually initiates the pipeline and provides some parameters. The home mixer contains a bunch of classes called feature hydrators that populate these features with values. Logically, this DDG stats Elon feature would make the most sense to be populated after the pipeline is completed. You can't really know if a tweet is from Elon until you've actually collected the tweet, right? So why does this feature get applied to pipeline query and not pipeline result or tweet candidate? And if this feature is supposed to indicate whether or not a tweet is from Elon, why is it a long? Shouldn't it be a Boolean? We've hit a dead end with our exploration here. We need to come up with another angle to approach this. Let's take a step back and look at what happens when the home mixer receives a request. We can then follow the flow of data from this entry point and hopefully end up close enough to where we started to get some answers. The class home mixer server starts two servers, a thrift server and an HTTP server. They both allow pipelines to be run, but we are just going to focus on the thrift server. Thrift is an RPC framework similar to gRPC. It allows you to define a service and then generate code in various languages to implement that service. It's kind of a pain in the ass, but I digress. When a home thrift request is received, the thrift server handles it with home thrift controller, which uses Stitch to determine which service to dispatch the request to. There are two services, URT service and scored tweet service, which is the one we care about. Scored tweet service then uses the pipeline registry to determine which pipeline to use for this request. At this point, home thrift request becomes a pipeline request, and the pipeline is run. The particular pipeline we are interested in is the for you pipeline. The top level config for this pipeline contains configs for a bunch of other pipelines. Scored tweets recommendation pipeline config is the main tweet recommendation layer. This fans out to 4 more pipelines. This also brings us back to that request query feature hydrator type from before. Home Mixer makes a call out to CR Mixer, which is where out-of-network tweets are sourced. Over in CR Mixer, we can see that there's a handler for get tweet recommendations, which is what Home Mixer calls. Following the request, it gets passed to build CR candidate generator query. Inside this function, we can see that the client context and product from the request are used by this params builder type. There's an optional parameter that allows the caller to override the feature map, but it's not used in this case. Therefore, all the params are populated using the client context. Once this query is built, it is passed to CR candidate generator, which ultimately fetches candidates from other services running machine learning models. There's a separate repo that contains all the machine learning models, and the configuration for the heavy ranker model does not indicate any references to author is Elon. In conclusion, DDG is Twitter's internal A/B testing platform. DDG Stats Elon feature is a feature that is used to track metrics for A/B testing. All current evidence I've been able to gather indicates that this is not used for anything that could introduce algorithmic bias. Also, the fact that the feature's value is a long and not a Boolean indicates that it is not used for inference, but rather for metrics collection. Here's what I think happened. Someone was looking to measure the impact of a change on certain cohorts of people. In order to deal with the high volume input, they had a filter on which tweets were actually collected for this experiment. The filter simply checked if the user ID of the tweet matched those features on the pipeline query. While this might seem a little weird, if the data volume was high enough, this could reduce the impact of this experiment on the rest of the system. Of course, this is all just speculation, but it seems like a reasonable explanation to me. On top of that, the commit message that removed this code was remove stats collection code measuring how often tweets from specific user groups are served. There we go. Twitter's code is a really good example of the average big tech company's code base. When I worked for Meta, I saw a lot of code that looked very similar to this. It's very verbose, not very intuitive, with little to no documentation. That being said, it is very modular, with an architecture that is very deliberate. I don't really know Scala, so I can't really comment on the quality of the code, but it seems to be pretty standard for a JVM-based language. Is Twitter going to continue to publish their code? In short, yes, it seems so. They fairly recently published some new code to the repo. However, I really don't think it's their top priority, which is fair enough. It doesn't really add much value to the company, and it's a lot of work to maintain. It's mostly just a PR move. Although, it would be nice if they could at least make it buildable. I don't think they're really serious about accepting contributions. If they were, they would have a proper contribution guide, and they would have a way to build the code without referencing internal dependencies that are not open source. Thanks for watching all the way to the end. If you liked this video, consider giving it a like and subscribing. If you have any questions or comments, leave them down below. I'll try to answer them as best as I can. You can also chat with me and other viewers on my Discord server, linked in the description. If you want to support me and my open source work, consider becoming a sponsor on GitHub. It helps me pay for things like hosting OpenTogetherTube. I'm planning on making a video about that soon, so stay tuned for that. Thanks for watching. Subscribe for more cool stuff.